talk about a couple of things. We are going to today do a little bit with solving with exponents some more. So just kind of giving you a timeline for the week. We'll do a little bit of exponent solving. We're going to take some notes on logs. Okay, so today we finally get to use that log button on your calculator you've been asking about. Tomorrow we're going to continue with the properties of logs. And on Wednesday we're going to do some solving with logs, kind of like we're going to do some story problems today with exponents. Which means then on Thursday, we're going to review and take our practice test. And our test this week is going to be on Friday over chapter 5. I am going to tell you right now that chapter 5 by far has the most low test grades of any chapter in the whole unit or the whole class. So if you are thinking to yourself right now, I kind of don't get what Miss Boyer was talking about, but I don't really care. I'll get it eventually. You probably won't get it eventually unless you find time to meet with one of us, either before school or after school or during reading time.
Well, Ms. Rumsey, let's write this down so that all 3 of your classes have the same information.
Yeah.
I'm available reading time, Tuesday or Thursday. Grab a pass from me or Mrs. Rumsey.
So Boyer has reading time.
And then I can stay after this week. Tuesday, Wednesday, and Thursday. I could stay after today, but I'm in a staff, like a department meeting, so you would work on your own. But if you really wanted to stay, I could, pop out and see what's up and answer any quick questions that you have. So Monday is a little more independent, but...
and Monday kind of as needed.
Right.
This week, I have a reading time on Thursday.
You do? That's exciting.
I know, I'm pretty excited about that myself. And I think that I can do after school on Tuesday.
Could you scoot that over just a tiny bit, Miss Rumsey? There you go.
I might be able to do after school on Wednesday if we have too many people who need to stay and they can't fit all in.
Right.
Otherwise, if we don't have too many people and Boyer can do them, then that's cool too.
Yep.
So, for sure I can stay after school tomorrow because Hannah got cut back to physical therapy once a week, which is way better than twice a week. So we have one more day in our lives here. But if you need help, I would come in and get your help before your test. Don't wait till you take your test and then go, oh look, I got an F. Because that is not going to be very helpful to you. All right?
No, and grades were looking really nice, most of them after that last test, because that last test had a really nice high average.
It did, even though it was a hard test.
Right. So we don't want to knock that average down or your own personal grade down with this. Plus we have all those technology resources. You can go back and watch all our videos. You can go on YouTube and find another video. You could make your own thinking maps to organize your notes.
So many choices, Miss Boyer. So many choices.
I know.
Okay. So we will put this on the board as well, but if you need assistance, please try to get yourself in for one of those times. All right, so today, we are going to be looking at a couple different things today. The first thing we're going to be looking at is 5.4. And 5.4 is applications of exponential properties, or applications of exponents. And so why would we care about these exponent things? What can we do with them? How can we use them? Kind of the story problems, if you will. I know how much we like story problems. And for our story problems with exponents, we're frequently going to see things like, in the example in the book, is Rita wants to invest $500 in a savings account so that its doubling time will be 8 years. What is the annual percentage rate necessary for this to happen? Assume the interest on the account is compounded annually. Those sound like really tricky problems. Other ones that would use that are things like, if a colony of bacteria is decreasing at a rate of such and such and so and so, when will the rate of the number in that colony be this? If an antibiotic works by killing bacteria at this rate, when will the bacteria be down to a normal rate of? So all of these different kinds of problems and exponents have applications in business, they have applications in marketing, they have tons of applications in science, in nursing, in the medical field in general. Lots and lots of places that you would use this sort of a problem. And they all kind of start with the same basic premise. So, to set up a story problem with an exponent in such a way, generally speaking, they're all going to follow the same exact pattern. It's going to be the new amount. Whether they tell you the new amount, or whether they say, when will the amount be such and such, or how much will the amount be after 5 years. Whatever the new amount is, or your answers part, is going to equal the original amount, whatever you started with, times the rate, raised to the power of time. So the original amount times the rate of change, raised to the power of time. So in the example that I gave you at the beginning, Rita wants to invest $500 in a savings account so that it's doubling time and will be 8 years. What is the annual percentage rate necessary for that to happen? Well, in order for it to double, the new amount here would be what? Put in a 500. She wants her new amount to be
1,000.
1,000, right? Because that's double of 500. 500 times 2 is 1,000. So here you would have the 1,000, the new amount. She tells you she wants it to double. Is going to equal the original amount, the 500, times the rate. That's pretty much what we're looking for. Raised to 8 years, or 8 in this case, because the whole thing is in years. And the only place that it gets a little tricky is when we're evaluating the rate. So, for the rate, if your amount is getting bigger, so we're growing larger, like the amount in her savings account is growing larger, you're going to use, in parentheses, 1 plus whatever that amount is going to be. And if your amount is getting smaller, you're going to use 1 minus whatever that rate is going to be. So if we're growing, sometimes they use the word appreciating, increasing, lots of those words about getting bigger. You're going to have 1 plus some rate value inside your parentheses. And if you're getting smaller, you're going to take 1 minus the rate value. And the reason we're doing that is because, mathematically, then what we do is we take the original amount times 1 to have itself, plus the original amount times the rate, so it'd be that much bigger. So let's just say something like our original number is 20, and we want that to get bigger. If we just put in the rate here, like 0.5 times 20, it's really not going to get bigger, because 20 times 0.5 is only half of that, or 10. So instead what we say is, okay, we're going to multiply that by 1 plus 0.5, or 1.5. The 20 times the 1 and the 20 times the 0.5, so that the number is going to get bigger. So we're going to start with this part, which is our original 20, and then essentially we're going to add 20 times the 0.5, which is half of that, so that our new number is bigger than our old number. If you were to forget the 1, and you put that in your calculator, and you said her money is increasing, and after 1 year, she had $10, does that make any sense to us at all?
No.
No, because then it's not increasing. By the same token, in order to make it go smaller, we have to do the same thing. We have to multiply by the 1 first to get the original amount, and then by the other part to get what part we're taking away. So 1 minus that. A lot of times, like if this was 0.25, I just subtract it early, like 1 minus 0.25 is 0.75. So even when I take away 25%, there's 75% of the animals left.
You know, that, the way I think about that too, so that it's kind of real world thinking, is if you were at Target and you bought an item and you had 6% sales tax, you don't pay for that separate. You don't pay for your item and then that goes through and then you don't pay for the tax separate. You have to add it together, the original price plus. And that's where that 1 comes in to help make sure. Or same token, if you're at Hobby Lobby and it's 90% off clearance aisle, you know, it's 1 minus. So kind of that same concept, just to help you think it through one more way.
So we are going to try a couple of problems with exponents and solving. The first ones are not story problems. So these are on page 263. We're going to do number 1, number 2, number 3, and number 11 for now. 1, 2, 3, and 11.